How does the sliding filament theory in muscle contraction work? Let's go. So first and foremost, an action potential reaches the sarcolemma of a neuromuscular junction. This causes an action potential to travel down the transverse T tubules to the sarcoplasmic reticulum. This causes calcium ions to be released from the sarcoplasmic reticulum, and then they bind to troponin. Troponin moves tropomyosin out of the actinomyosin binding site. So tropomyosin is covering the actinomyosin binding site. It then moves tropomyosin out of the way. Okay, now this allows an actinomyosin cross bridge to form. Okay, so what this means is that the myosin heads bind to the actin filament and form a cross bridge. Okay, and then ATP is hydrolyzed using ATP hydrolase, and this provides energy for the myosin head, which has now formed a cross bridge with the actin filament to bend in the form of a power stroke. Okay, then ATP attaches to this myosin head and causes it to detach from the actin filament, and then the process repeats essentially with another part of the actin filament, and then it continues until the muscle is fully contracted. The calcium ions are then actively transported back into the sarcoplasmic reticulum once the process is finished, and that, ladies and gentlemen, is the sliding filament theory in muscle contraction.